2.3, importing one of the package's modules from another module in the same package. So we're going to look at relative and absolute import statements and what to do when two modules import each other. So we're going to look at how Python 2 and Python 3 have slightly different rules for how import statements find packages. When we're importing one of a package's modules from outside the package, there's only one sensible way that it could work. We tell Python which package and module we want, and either finds and imports it, or raises an exception if it can't. Simple. When we're already inside a package, the situation is more ambiguous, because import module could just as easily mean look for the module with that name within this package, or look for the module with that name on the Python search path. Python breaks this ambiguity by defining import name that a package or module called name should be searched for in the Python search path, and by giving us a way to specify a relative import if we'd rather have it look just within the current package. We can specify a relative import by putting a dot in front of the name of the module we want to import. When Python sees that, it will look for a module called module in the same package as the module our code is running in. Often we only need one or two objects from another module. It's more convenient to import those objects directly into our global scope than it would be to import the module as a whole and access its contents as attributes. Python lets us do that with a slight variation of the import syntax. Finally, sometimes we want to rename an object within our scope as we import it. We can do that by modifying our import with the as keyword. In this example, even though the object is called foo in the module named module, in our current module, it's named bar. Before we move on, let's take note that Python 2 used a different rule for deciding where to find imported code. In Python 2, it first tried to find the targeted import within the current package. Then, if no matching module was found there, it went out and looked for it on the search path. That approach usually did the right thing, but occasionally caused problems due to the ambiguous meaning, and it meant that we couldn't have subpackages or modules that shared the name of anything in the standard library or other installed packages. So this behavior was changed in Python 3. There's something that might trip us up when we're importing a module that shares the same package. Sometimes, in a module that doesn't import, the imported module wants to import the original module. This is called a cyclic dependency. When we import a cyclic dependency, we'll almost always get an attribute error exception, as in this example. That happens because when we ask Python to import the first module, a.py, Python immediately creates a module object for it and begins executing the code in the module. That's fine, except that when Python gets to the import statement for the b.py module, it pauses running in a.py, leaving it not fully initialized, and proceeds to execute the code in b.py. Even that normally isn't a problem because Python will come back and finish the initialization later. However, when the second module asks to import the first module, Python just hands it the already allocated and not fully initialized module object. When the second module tries to access the variables stored in the first module, many of them will not have been created yet. Hence, the attribute error is raised. There are two common ways to address this problem. The first, and usually the best, is to break the cycle by taking some of the code from one of the modules and moving it into a third module. Both other modules can import without causing a cycle. In this example, if we move the A class into its own module, there would be no cycle and all would be well. The other way to address this problem is to move the import statement that causes the cycle. If we move the import statement down until it's below all of the variable definitions that are needed by the other modules in the cycle, the module will be initialized enough when it's imported by the other modules. Python will still come back later and finish the initialization. So relative imports look like from .import module or from .module import variable. Absolute imports look like import package.module name or from package.module import variable. If two modules import each other, move some of the code to a third module, or import one of the modules at the bottom of the other. Now we have a pretty good handle on importing within a package. Let's move on to adding data resources to the package.